Hello, Mrs. Snowden here, and we're going to talk about properties of real numbers. So, when we talk about real numbers, we use a capital letter R, and it's hard for me to type, but some of you have seen it before with the double letter. Okay, so that's a real number. Sometimes you can just use a capital R. So, a real number is any number that can be put on a number line. I can say this is its exact location. They are either rational or irrational. Okay, so let's talk about these rational numbers. So we've already used the capital letter R, so when we talk about rational letters, you see the letter Q. So rational numbers can be written as a ratio or a fraction. M over N. The decimal form is either terminating or repeating. For example, terminating, 1.2. Okay, that's a terminating decimal. 0.3 repeating. We put the bar on top, 0.33333. And that's because 0.333 can be written as 1/3. 1.2 we can read 1.2 we can write as a fraction as 6/5. Also things like 7, because I can write that as 7 over 1. You might see things that look like 0.27 repeating, as long as it has that bar on the top. You might see the square root of 9, because we know the square root of 9 is 3, and then we can write that guy as a fraction. Also something like 0, because we can put it any denominator under 0. Okay, so all those are forms of rational numbers. Irrational numbers, we use the capital letter I, thankfully that's not taken, but for lack of a better definition, they're not rational. Their decimals don't repeat or terminate. So our most famous irrational number, pi. Okay, it doesn't stop and it goes on forever and ever and ever. Square roots of numbers that we don't know, like the square root of 3. That's not a perfect square. That's not one that we know. And then crazy things that happen where it has a pattern, but it doesn't repeat and it doesn't stop. Okay, those 3 little dots right there say it goes on forever. So it might have a pattern, but it goes on forever and it doesn't stop. All right, so we have real numbers. Those real numbers are broken down into rational or irrational. And then when we talk about rational numbers, these guys up here, we have some subsets of them. The first one is the integers. Well, we've already used I, so I don't know why, but they picked the letter Z. Integers, think about the nice big numbers. If you were going to draw a number line, the positive and negatives on a number line, okay? So this bracket right here just means it goes on forever. This way it's the set of. I'm going to do 3 little dots. That just means it goes forever in that direction. Like that. So think about if you're going to draw a number line, those would be the nice pretty numbers on it. Whole numbers. Whole numbers are numbers, they use the letter W. Whole numbers don't include the negatives. It starts at 0 and goes up. If you notice, I remember whole because there's an O in the middle. There's a 0 right there. Starts with a 0. And then the natural numbers, think about when you naturally start counting as you were a child. When you learned how to count, Mom started you out with 1, 2, 3, and so on and so forth. Okay? So, all natural numbers are whole numbers, and all whole numbers are integers. And if you noticed, all of these, there's no decimals and no fractions. Okay, I'm going to draw you a Venn diagram. so we can kind of break it apart. Okay? So here's my Venn diagram. I'm going to draw them up and down because that's the way I have room on my paper. But these guys are all real numbers. Here's my real numbers. I'm going to use the letter R. That circle right there represents my irrationals. Okay, so those guys are the irrationals. This circle represents the rationals, and we're going to use the letter Q. Obviously, there's a lot more of them, so I tried to make it a little bit bigger. Inside of those rationals, we have integers. And inside the integers are the whole numbers. And inside the whole numbers are the natural numbers. So every natural number is a whole number. It's an integer, it's rational, and it's real. Now, as you notice, irrational numbers cannot be rational. So if I find out that it's a natural number, it can't be irrational. All right, so number 1 there says, name the sets of numbers to which each number belong. And you can use the letters, okay? So, -4. First of all, we're going to decide, is it rational or irrational? It's a real number. I can write it as a fraction. I can put it on a number line. So it's real and it's rational. I'm just going to use the letters. RQ. If I look at my integers, -4 would be on there. Oops. So it's a Z. R, Q, and Z. The whole numbers and the natural numbers don't include negatives, so that guy's just real, rational, and an integer. 45. He's real. He's rational. He's an integer. He's a whole number, and he's natural. RQZWN. 6.23 repeating, it's got the bar on top. So this is a repeating decimal. So he's real, he's rational, but remember he's no decimals and no fractions. So he's not an integer, he's not a whole number, and he's not natural. So he's just R and Q. Letter D, 6.3842 goes on forever and doesn't stop, doesn't repeat. This guy is real and irrational. Letter E, 0. He's real. He's rational. He's an integer, and he's a whole number. 0 is the only natural number, or only whole number that's not a natural number. Letter F, pi. He's real and irrational. Letter G, the square root of 25. Go ahead and simplify that. And now we're going to classify 5. He's real, rational, integer, whole, natural. And last one, the square root of 29. That's not one that I know. So this guy is real and irrational. All right, so those were the number sets. Now we're going to deal with properties of them. Properties of number sets. Some of these we used when we were doing geometry proofs, and these would be like our reasons when we were doing a 2-column proof. So we have the commutative property of addition and multiplication. When you look at that, you see that the order changes. They move, okay? I hear the word commute, the order changes. A plus B equals B plus A. They've switched their location on either side of the equal sign. Associative property, and we have it of addition and of multiplication. Well, look at who they're grouped with. Who are they associating with? Here, A plus B are associated together, and then B plus C are. A and B, B and C. So they're grouped differently. Identity. Think about you as a person. You don't change. So what do you add to something to not change that number, and what do you multiply to something? Will you add 0 and the number doesn't change? You multiply by 1 and you don't change either. Inverse. Inverse. I'm going in reverse. I'm undoing it. Inverse, reverse. So you're going to undo it. I add the opposite, so I equal 0. I multiply by the reciprocal, so I equal 1. Okay? So on identity, I'm adding 0 and I'm multiplying by 1. On inverse, I'm equaling 0 or equaling 1. And the distributive property, you're just sharing. A gets distributed to B and C, or A gets distributed to B and C. All right, so now we're going to decide which property this is. So looking down here at number 2, I have, and the first thing I'm going to check to see if they're in the same order. 3, 4, 25, 3, 4, 25. They're in the same order, so it's not commutative. But in the first one, I have 3 and 4 grouped together, and then I have 4 and 25 grouped together. So this is my associative property. Now, technically, it's the associative property of multiplication, but if you can identify it as associative, I'm a happy lady. Letter B, 5y times 1 over 5y equals 1. I'm undoing it so that I equal 1, so this guy is a inverse. And technically, it's a multiplicative inverse, but like I said, I'm a happy lady if you can identify it as an inverse. Letter C, I'm going to check my order first. 2, 14, 3, 2, 14, 3. Okay, it's not commutative. I have 2 and 14 grouped together on the left side. The right side I have 14 and 3 grouped together. So this one is also associative. Technically, like I said, it's the associative property of addition, but if you can identify it as associative, I am the associative property. Again, I'm a happy lady. Okay? All right, turn the page. Now we're going to practice using those. All right, so number 3, it just says distribute. So I'm going to distribute a root 3 to both a 2 and an x. So 2 root 3 plus x root 3. And then I'm going to distribute a 2 in number 4. So I get 2r plus 2w. Number 5 says simplify the following expression. We could have also said something like combine like terms. So I have 3x plus 4y minus 5x. I have a positive 3x and a negative 5x, so when I combine them, I get a negative 2x plus 4y. Now you could have also written that as 4y minus 2x, but that's because of the commutative property. You can change the order and it still equals the same thing. Normally we write them in alphabetical order, but it really doesn't matter. All right, number 6. I have a 9p and a 4p. So 9p plus 4p is 13p. Then I have a negative 2n and a positive 2n. Those two are going to cancel, so I'm just left with 13p. Number 7, I have to distribute first. So I'm going to distribute a 3 to the 5c and the 4d, 15c plus 12d. And then I'm going to distribute a 6 to the d and the negative 2c. So plus 6d minus 12c. All right, I have a 15c and a 12c, negative 12c. 15 minus 12c is 3c. And then I have a 12d and a positive 6d, so I get 18d. All right, number 8, last one. Just be very careful with this one, because as you notice, I have to distribute a fraction. Now the 1/2 isn't too bad, but when I distribute the fraction for this guy, it's a negative 3/4. So I'm going to flip the sign and give it to the negative 3. just so that I remember to distribute the negative to both of them. All right, so 1/2 times 16. Half of 16 is 8. 1/2 times a negative 4a gives me minus 2a. All right, let's do it a step at a time. I know fractions aren't always our friends, but let's do it together. Negative 3 times 12 would be negative 36. Divided by 4 would be a negative 9. Again, negative 3 times 12 is 36. Divided by 4 is a negative 9. Okay, let's do it again. Negative 3 times 20 is negative 60. Negative 60 divided by 4 is negative 15. And we have an A with that guy. So then I can combine like terms. Thankfully my fractions went away. Negative 1, and then I have a negative 2a and a negative 15a, so minus 17a. And that is the second section, properties of real numbers.